So we have limit as x approaches infinity from arc tangent of natural log x. So these are two functions that we should know of by now, right? So when we graph natural log, remember this is the graph. So when x approaches infinity, natural log approaches infinity. So then this approaches infinity. And now we want arctangent of infinity. And we know the graph of arctangent, which is this. And it's between pi over 2 and negative pi over 2. So obviously, when we are trying to determine arctangent when x approaches infinity, then we will say pi over 2. We had this on a previous test. So I'm hoping that by now you've done those tests several times. This should have been one of them on one of the tests. Okay, the next one I think we've seen, but we move on to B, or do you need more time? Or
can you explain that one more time?
Yes, this one. Mm-hmm. So every time we are asked to find a limit, we have to sort of plug it in. So limit of natural log, or natural log of infinity is infinity, and arctangent of infinity, according to the graph, is pi over 2. Is that better, everyone? Yes? Okay. Next one needs to be simplified. We can touch this, and it says you must simplify the function completely first before you do anything else. Is this okay so far? Okay, so we have to start with the absolute value of x minus 1. So you can write this as 2x minus 1 divided by the absolute value of x minus 1. But first we have to simplify the absolute value. And we know that there are two possibilities. One of them is x minus 1 for x greater than or equal to 1. And the other one is negative x minus 1 for x less than 1. Now stop me if you have any questions on this. So therefore, this expression has two possibilities. I know you've done this in pre-calc. We also have done it together. So if you have any questions, I'll go back to it. So I have to express this with no absolute value. So 2x minus 1, the absolute value of x minus 1. There are two possibilities. When the denominator is x minus 1, then I will simplify, and the answer is 2. But I cannot include 1. Can anyone explain why this time, for this function, I cannot include 1, but I was able to include 1 over there? It's undefined. It's in the denominator. Actually, it's 0 over 0, but yes. So the other possibility is when the denominator is negative x minus 1, so the answer will be negative 2 for x less than 1. And now I can determine any limit. So the limit was, as x approaches 1 from either side, from 2x minus 2 over the absolute value of x minus 1. In order to have an answer here, I have to determine both limits. I have to write that. And I'll say that the limit as x approaches 1 from the left is from negative 2, and the limit as x approaches 1 from the right is from 2. The first one is negative 2, the second one is 2, so obviously there is no answer for the limit from either side. Is this okay? Any questions here? Okay. Now limit as t approaches 1 from the right, 1 over t minus 1. No, t, I'm sorry. T over t minus 1, 1 over natural log t. I would love to apply a limit law, but I can't, because the limit from the first one is not a number, and the limit from the second one is not a number. So therefore, I have to do something else. I have to try to first find the least common denominator. And get t natural log t and minus t plus 1. Remember, we multiplied the top of the first one by natural log t and the top of the second one by t minus 1. Is this okay? Stop me anytime if you have a question. I don't want to just go over problems if you have questions. Okay, now I'm going to try again. So 1 from the right, this is 1, but this is 0. This is 1, and this is 1. So 0 minus 1 minus 1 plus 1 is 0. Again, this is 0. This is 0. My apologies, I didn't need the parenthesis here. Okay, so 0 over 0. Now I know what we can do. So I did see on this test that I just returned today, I saw that you differentiated a product using L'Hopital's rule. We can't do that. So L'Hopital's rule works only in these two situations. So if you have a product, you cannot just simply differentiate the product, because that's not going to work. It's not allowed. So we use L'Hopital's rule only inside a limit and only when we have these two situations. Is that okay, everyone? Yes? Okay, so let's continue. Limit t approaches 1 from the right. So I will apply the product, I will apply L'Hopital's rule, but also the product rule here. So when t prime is 1, so I get natural log t plus t times 1 over t. This was on a previous test also. And minus 1. Yes, please. First function, second function. First function prime is 1 times the second function plus the first function times the second function prime times minus this prime, which is negative 1. The same thing, the product rule in the denominator. The first function prime is 1, natural log t plus t minus 1 times 1 over t. Same rule, product rule. Is this okay? Please say no if it's not, so I can repeat it. Are we okay? Are we okay? Questions? Okay, very good. Okay, moving on. So this is a 1 when I simplify it, and 1 with negative 1 will go away. So the numerator is just natural log t. Do we all see that? Yes? T times 1 over t is 1. 1 minus 1 is 0. Better? Good. So now the denominator, I have natural log t. I will distribute 1 over t. So I have plus 1 minus 1 over t. Okay, we check again. The numerator goes to 0. Let's see the denominator. This goes to 0. This goes to 1. 1 minus 1 is 0. Still safe to apply L'Hopital's rule. Is this okay? Yes? Okay, so now we continue limit. T approaches 1 from the right. So the top is 1 over t. And now I differentiate 1 over t, but plus 1 over t squared. So the numerator prime is 1 over t. In the denominator, natural log t prime is 1 over t. 1 prime is 0, and we differentiate this. We know that already is negative 1 over t squared with minus in front, 1 plus 1 over t squared. Moving on. Yes, everyone? Okay, so what I would like to do now, if you allow me, if you don't, I'll find another way. 1 over t at the top, and I factor 1 over t from the bottom. And I get 1 plus 1 over t. 1 over t times 1 is 1 over t. 1 over t times 1 over t is 1 over t squared. And you see the reason why I did that. Only because I saw the top has 1 over t, and the denominator has a factor of 1 over t. Now, if you don't want to do that, then you have to find the least common denominator, and when you're done, flip this and multiply by 1 over t. It's one or the other. So now when t approaches 1, the denominator approaches 2. The numerator is 1, so the answer is 1/2. I think we had this on the test that I just returned, if I'm not mistaken. The third problem in It was the same thing. So I'm hoping you will redo all your tests multiple times. Okay, any questions on this problem? Any questions? Okay, moving on. Do we move on to cosine? Yes? Or we want to do something else? Or yes, okay. So limit as x approaches 0 from cosine x raised to 1 over x squared. So what do we do here? Yes, so first of all, I have to denote the function by y equals cosine x raised to 1 over x squared. And before that, we have to identify the indeterminate case. So when x approaches 0, cosine approaches, very good, 1. And 1 over 0 is, regardless, is infinity. On one side or the other is still infinity. Okay, very good. So we apply natural log. So we get 1 over x squared, natural log of cosine x. So this is wise to, if you would agree with me, to rewrite it like this, which is the same thing. Now we're going to find what? What is the next step? We're going to find the exactly. We're going to find the limit as x approaches 0 from natural log y, which is limit as x approaches 0 from natural log of cosine x over x squared. Very good. Now we check again. When x approaches 0, this is 1. Natural log 1 is very good. And it's 0 over 0. So we changed 1 to infinity into the case of 0 over 0, which we like. Why do we like 0 over 0? L'Hopital's rule. Perfect. So limit as x approaches 0. Very good. 1 over cosine x times, very good. Very good. Negative sine x over 2x. Here is my recommendation for the next step. When x approaches 0, where does 1 over cosine go? Perfect. So basically what I'm facing here is this. And I know this from a long time ago. Where does this go? Perfect. So what is the answer? So if you, yes, Vanessa?
I'm confused where you got 1 over cosine x to equal 1 at the top, like when you circled it.
Yeah, when x approaches 0, cosine approaches 1.
And that was just cosine, it's 1 over cosine.
1 over 1 is still 1, right? So if the numerator is 1 and the denominator approaches 1, 1 over 1 is still 1. So if you had made the mistake to change that into negative tangent, I wouldn't say mistake. If you had changed it into a negative tangent over 2x, you would have obtained the same answer, because you eventually would have said negative 2 secant squared over 2, and you would have gotten the same answer. So, however, I just wanted to remind you this, because this is a very important limit. So from here, if you want, the other option would have been limit as x approaches 0 from negative tangent x over 2x. And this is, again, 0 over 0. And you will differentiate the top. So this is limit as x approaches 0, negative secant squared x over 2. And when x approaches 0, secant approaches 1. So this is still negative 1/2. But I wanted to refresh your memory on this because this is going to be on final. This is such an important limit. So please make a note of it. I mean, once you review all the tests, I'm sure you'll come across that. And after test 4 on Saturday, I will post the solutions for test 4. So over the weekend you have, over the weekend you have all 4 solutions for tests. Okay? Is that okay? Moving on. Questions? Ricky, questions? No. Okay. So limit as x approaches infinity from x plus the square root of x squared plus 2x.
It's negative infinity.
Thank you. Thank you. When x approaches negative infinity, where does this go? Careful. Perfect. When x approaches infinity, where does this go? Perfect. Well, that's a situation. Very good. It's an indeterminate case, one of the 7 indeterminate cases. What do we do? And it's the only way. Say it again. Yes. Say it again, Savannah. We rationalize. Yep, we have to rationalize. X minus the square root of x squared plus 2x, x minus the square root of x squared plus 2x. So this is limit as x approaches negative infinity. X minus the square root of x squared plus 2x. And can anyone give us the numerator?
Yeah. X plus x squared
Yes?
minus
Yes?
x squared
Yes?
minus 2.
Very good. First term squared minus the second term squared, and we have to distribute. Everyone on board with this? Questions, please? Anyone, please? Okay. So these two go away. Obviously, we have to do our magic inside the square root. What do I do?
X squared
Very good. I factor out x squared. Limit as x approaches negative infinity, negative 2x over x minus. We factor out the degree. What is left in parentheses?
1
Plus
2
over. Very good. Excellent. Now I have to remove this and put it out. But this is extremely important. This will tell me what goes out from the square root. So the square root of x squared when x approaches negative infinity will be replaced by negative x. Awesome. You got your extra credit. You're way over. You don't need any more.
number here.
So limit as x approaches negative infinity, negative 2x, x plus x, the square root of 1 plus 2 over x. Let's take a look and see if we have questions before we continue. All steps clear, yes or no? And we've seen this before, but it's been a while. So nothing is new, of course, but it's been a while. So are we okay? Okay, so now I'm going to factor out x and eventually simplify it with the x from the top, but I have to factor it first. So limit as x approaches negative infinity, negative 2x, x outside 1 plus the square root of 1 plus 2 over x. Finally, the problem goes away. And now you tell me the answer. Where does the top go to? Very good. Where does the denominator go to? 2. So the answer is negative 1. Yes, Vanessa?
I know how you got that, like it's x plus x and then square root of 1 plus 2 over x.
Yes.
Then you get to the next step for the denominator.
I factor out x. X times 1 is this, x times the square root is that. If I don't factor it out, I cannot simplify with the x from the top. I have to factor first before I simplify. Other questions on this one? We've seen this one before. It's in your notes. I promise, again, as I promised the entire semester, I'm not going to invent anything. So if it wasn't done in class, you're not going to see it on the test. Okay, so limit as x approaches infinity, e to 4x minus e to negative 4x over e to 4x plus e to negative 4x. Where does this go? And where does this go when x approaches infinity? Remember, that is 1 over e to 4x. So when x approaches infinity, where does this go? Of course. Of course. The negative power brings the expression to the denominator. So now where does this go? And where does this go when x approaches infinity? Infinity, very good. So really we have infinity over infinity. You could think in terms of L'Hopital's rule. It's much easier than that. I would factor. So let's factor. What will you factor out from the top? And like before here, we factored out the degree, right? The most powerful one. Let's do the same thing here. Which of these two is the most powerful? I know it's a silly question. Yes, e to the 4x, we can force it out from both because then I'll get rid of it. But the question is what is left in parentheses? Exactly. 1 minus in both cases. 1 minus what? Plus in the denominator, though. 1 minus what? Yes? Yes? From, yes, from negative 4x, of course, I subtract 4x. So it's negative 8x. Let's say, I'm not sure. Okay, let's put it back in, as if we would like to put it back in. We don't. E to 4x times 1 is that, right? E to 4x. But when you multiply these two, you have to copy the base and add the exponents. And when you add 4x to negative 8x, you get negative 4x. Good. So now we know that this is going where? Perfect. We know that this is going, and the answer is, that's it. Yes, Vanessa?
And then talked about the e to the 4x.
Mhm.
That's a 1. Wouldn't it be 1? Oh, never mind. There's a 1 in the
Yes. Better? Okay. Do we need to look at any of the problems for test 4 review, or we can find the test 4 review here? Because I still would like to review a little bit for, I know we reviewed on Tuesday, but I think we should do a little bit more. So I think we should look at from 12 on and then come back to the rest. Because from 12 on, problems are for test 4. So look at 12, 13, and you choose. 12, 13, integrals, the midpoint rule on 14, and Riemann sum, part B, the total distance, part C, and the derivative of the function, part D. So please choose the next problem. Anything you want. 12? So we are given the second derivative as 4 plus 6x plus 24x squared. We are told that f of 0 is 3 and f of 1 is 10. Would you like to work on this for a minute or not? Okay, so let's wait for a minute and see what you get. Yes. Yeah, because when you differentiate for x, you get 4. Yeah, when you differentiate this, you get that. Yes, very good. Yes, and then f of x in the same way. Yes. Oh, exactly. Yes. Do we need more time? Do we need more time? So we determine the first derivative first, which is 4x plus 6x squared over 2 plus 24x cubed over 3 plus the constant c1. Simplify before you continue. Always do that, please. So 4x plus 3x squared plus 8x cubed and plus c1. We don't have any information about f prime, so you cannot use any of this yet. We will find the function in the next step. So we have f of x, which is 4x squared over 2 plus 3x cubed over 3 plus 8x to the fourth over 4 plus c1x plus c2. Simplify next. 2x squared plus x cubed plus 2x to the fourth plus c1x plus c2. We are given two conditions, and one of them is f of 0 is 3 and f of 1 is 10. They are helping us determine, they will help us determine C1 and C2. So f of 0, 0, 0, 0, 0, C2, right? So obviously C2 must be 3. So f of x equals 2x squared plus x cubed plus 2x to the fourth plus c1x plus 3. And now I have the second condition that says f of 1 is 10. So 1, 1, 1, c1, 3, and 10. So this is 5 plus 3 is 8, subtracted from 10, c1 is 2. So the only function that fulfills the given conditions is this. It should be written now in descending order. 2x to the fourth plus x cubed plus 2x squared plus 2x and plus 3. And this is the function. Are we okay with this? Yes, Ricky? Yes. Any questions on this? Any questions on this? Okay. Are we continuing with 13? Yes? Okay, so let's work on AB, and that gives Ricky a minute to copy. So let's start with A and B on 13. Ricky, are you okay? Yes, that's fine. I'll wait.
Did you get 3?
0, 0, 0, 0, C2 equals 3. from f of 0 equals 3. I have f of 0 equals 3. When I plug in 0 everywhere, I only get the constant left.
So how do you know which C value to plug in is fine?
I'm not plugging in c. I'm plugging in x.
I mean,
F of 0 equals 3 means when x is 0, the function is 3. I'm not plugging anything in c. I'm finding c. I don't have c. Is that clear?
yeah.
You want me to go back? Is it clear how we got the function? Yes? That step is clear?
Yeah.
Okay, so now f of 0. 0, 0, 0, 0 times c1 is 0, plus something equals 3. What can the something be? Exactly. So then
How come we can't do F of 1 plus?
you can, if you want to do that, that's fine. You can do that.
Well,
But if you plug in 1 first, then you'll have two unknowns. You still have to wait till you plug in the first one. See, when you plug in 1, you'll have 2 plus 1 plus 2 plus c1 plus c2 equals 10. You have two variables now. You still have to wait till you plug in the first one. So once you plug in the first one, you get c2. Then you rewrite everything with c2 inside, replaced. And then you use the second condition to get c1. If you use the second condition first, you're gonna still have two variables in the function. Is that clear?
yeah.
Do we have the answer for the first one or not yet? So what function prime is 1 over t? So first of all, remember the interval is 1 to 4. Are all these defined? Yes. So then I can write natural log t. The absolute value will not be required because it's 1 to 4, but I have to put it at first. Minus plus 3t cubed over 3, which will go away, from 1 to 4. So first we plug in, by the fundamental theorem of calculus part 2, we plug in 4. So this is natural log 4, no need of absolute value, minus arc tangent 4, plus 4 cubed, which is 64, minus, when we plug in 1. When I plug in 1 in natural log t, what do I get?
0.
Perfect. When I plug in 1 in arc tangent, I get an angle. Very good. Negative pi over 4. And when I plug in 1 here, it's positive 1. So natural log 4 minus arc tangent 4 radian, 4, and we'll get an angle. Plus 64, but minus 1 will be plus 63 minus plus pi over 4. And this is final. And I need to announce it that last time Savannah found, right? You found a second function that had the same derivative. So we did find an example. I don't remember what it was, but if you'd like to give it to me so I can put it here for everyone. So what we were doing, we were e to u over 1 plus e to u squared du, I think, and we got two options. Our option was negative 1 over 1 plus e to u plus a constant c, and your option was u over plus a constant c. So this is a perfect example. We looked at that. This is what we got. This is what she got. If you differentiate this or differentiate that, you'll get that. Guaranteed. In both cases. Although you can say it's not the same function. So we found two functions whose derivative is the same. But they are not the same. They are different functions. Was it correct, Savannah? Yeah. Yeah. At the end of the class last time, we sat down and we looked at her answer, which was absolutely perfect. Very good. Next question. That reminded me because I see the next one, which is the integral from 0 to 1. So the integral from 0 to 1 from e to u over 1 plus e to u to the 4th du. Any suggestions on this problem?
Substitution.
Yes? Which one? Let's say let y be. Yes? Yes? E to u. Only if dy is in the problem, or it can be easily made up. Excellent. Which is right here.
So, question.
Yes, please.
Now it is a fraction. We can do e to u du instead of eu over du.
We use a substitution. We said that this is a new function. So forget about the original problem. So we're looking now at a function that we called y, and it is 1 plus e to u. And we want to find the differential of y. Differential of y is this function prime times du. So when we differentiate this, we get e to u and then du. So now when we look back at the integral, we realize that e to u du, all this piece, can be replaced by dy. And now, how will I rewrite the integral? Do not copy the limits of integration. We know why, right? We can't. Because now the function is in terms of y, and we have dy.
1 plus e and 1.
1 over to the, that's it. Now the limits of integration. The lower limit first. When u is 0, how much is e to 0? 1 plus 1. Very good. And now we plug in 1. Well, e to 1 is 1, so the top is 1 plus e. Good. So what is the derivative? The antiderivative of 1 over y to the 4th. Better, always, in this case. What is the antiderivative of y to negative 4? Very good. Awesome. I would rewrite it as negative 1/3 times 1 over y cubed from 2 to 1 plus e. Of course, I will make negative 1/3 weight. I will plug in 1 plus e and subtract when I plug in 2, which is 1 over 8. And I will not do anything else. You can distribute if you want to, but it's not going to make a difference. Any questions? Any questions? Is this okay? Ricky?
Why is the limit 1 plus e?
So the lower limit for u is 0. E to 0 is 1. 1 plus 1 becomes 2. So we are looking to find the limits for y. If the lower limit for u is 0, the lower limit for y will be 2.
So you plug in.
I have to. This is a new integral in terms of y. I cannot copy the limits of integration for x. These are the limits for x. I have to determine the limits for y.
Okay.
So when I plug in 1, e to the first power is 1 E to the first power is E. E plus 1 is E plus 1.
Oh,
Is this okay? Questions? And no, in this situation, we cannot find two different answers. In this case, there is only one answer. For an indefinite integral, it's possible. That's like we've just seen a minute ago. But for definite integrals, no. Okay, the integral from cosine to the sixth sine x dx. We want to work on this for a minute or not? Okay. Okay, so we use a substitution. We say let y be you want to, of course, yes, cosine x. And now we want to determine dy. Excellent. Negative sine x dx. Awesome. I have sine x, I have dx. I am missing the minus, but that's not a problem. I can multiply by -1 twice.
Why is it,
Because when we differentiate cosine, we get negative sign. Yes, Vanessa?
Why do you put it on both sides though?
But if I put it just this, I'm changing the number.
I don't understand.
So can I say that 10 is the same with -10? No, but I can say that 10 is the same with -10.
Oh,
So if I put it twice, I didn't change anything. If I only put it once, I make a positive into a negative. But if I put it twice, I don't change anything. So this is incorrect, but this is correct. It's like, for example, if I need to put a 4, I cannot just put a 4. I have to put a 4 and also 1/4, which is 1. Multiplication by 1 doesn't change anything. So if I choose to put the 4, I have to put 1/4. Better? Okay, very good. So can anyone dictate the new integral, please? Yes? Yes, y to the sixth. Excellent. So it's negative y to the 7th over 7 plus a constant c. This is an indefinite integral. I have to go back to the given variable, which is -1 over 7 and then cosine to the 7th plus a constant c. Is this clear, everyone? Yes? Vanessa, is this okay? The integral from dx over 4x minus 1.